Well, we've been talking about solving equations with radicals in them. We're going to totally reverse that now and use radicals to solve an equation. The topic is solving quadratic equations using square roots. So let's just have a quick conversation about quadratic equations. What does it mean for an equation to be quadratic? What does that term mean? And hopefully you remember that the main feature of every quadratic equation is what? An x squared. That's what it means to be a quadratic equation. It has an x squared in it. And we've seen lots of forms of those. Most often, they've looked something like this. Y is equal to ax squared plus bx plus c, a second degree trinomial. But they've taken some other forms too. Uh, Often when we solve those, we don't have a y, we might have a zero. We would set it equal to zero if it's just a univariate, one variable quadratic. And then we might get it to look like this. And then we have some different methods of solving that. One is, you may remember, factoring the trinomial. And then we split those two factors up and we have them as something equals zero and something equals zero. And then we solve those mini equations and get x equals blank and x equals blank, right? They come from these numbers here that were in those binomials. Both of these numbers, here and here, whatever they are, would make the original equation true. That's what it means to solve an equation, right? We're keeping the basics in mind as we do this. Another way we solved quadratic equations was we could graph them, right? If you have an equation and you graph it and you see it looks like this, you can look at where it crosses the x-axis. And these 2 points, these two x values, x equals blank and x equals blank, are often called the zeros of the equation, and they'd be the solutions to whatever looks like that. So that's another way we can solve quadratic equations. Again, find the values of the variable that would make it true, and in this case, make it equal to zero. Well, we're actually going to learn another way right now. This can be a helpful strategy when your equation is in certain formats. Sometimes factoring is an obvious thing that you want to do. Other times, another approach might be better. It might be more efficient. So let's solve. We'll start simple, and we will say y squared equals 36. So we actually talked about this before in other cases. And I said, well, what are the solutions to this? What numbers make this true? And you might right away say, it's 6. I know it's 6. Well, it actually has 2 solutions because it's quadratic. And so we would say, oh yeah, it could also be -6. How do we formally solve this equation using some processes? We want it to say y equals something, which means we want to get rid of that exponent. Because it's a square, we can eliminate it by taking a square root to both sides. Just like squaring a radical cancels the radical, taking the root of a square does the same thing. So this radical cancels out that exponent. And you're left with y equals, and then the square root of 36. Now, I missed something here intentionally. You can't just take the square root of 36. You have to take the positive version and the negative version. Positive and negative answers to this. Often we use the notation plus or minus 36, but in certain online programs, including Alex, you're going to need to list them out separated by a comma. So we would say that the answers to this, the solutions would be 6 and -6. The square root of 36 and the negative version of square root of 36. Okay, so these would be your solutions. Okay. What if we have an equation that looks like this? X squared is x squared plus 9 is equal to 0. So in this case, if we're going to use a radical to try to solve it, we want to get the x squared by itself. We actually want to isolate this. So this is not a case where we set it equal to 0. We want to isolate this. So we would subtract 9 from both sides, leaving us with x squared equals -9. We would then try to clear off this exponent by taking the square root of both sides. And we would put a little plus and minus in front of that. We would take the square root of x squared, canceling the exponent, leaving us with x equals plus and minus what? Uh-oh. We have run into a case where we took the square root of a negative number, and you can't take the square root of a negative number and get a real number solution. We're not dealing with imaginary numbers right now. So we say that there is no real number solution, no real solution for this case. Okay, we don't have any options. You can't take the square root of a negative number. Now, just to connect this with other things that we've learned, you might have looked back here and said, hey, we factored differences of two squares, and isn't this kind of the same thing? This is a sum of two squares, and a sum of squares is not factorable, and it doesn't have any real number solutions because of this. Okay, let's look at a few more different situations. What if we have x squared is equal to 27? And we want to solve this. Solve. We're going to take the square root of both sides, plus and minus. We never forget that. We cancel the exponent, giving us x equals plus and minus the square root of 27. But you go back and read the instructions to the problem, like you always do, and you notice that it says simplify completely. That's always a signal that I might have to do something else once I get done. This looks like things we've seen before. A radical that can be simplified. X is equal to plus and minus. 27 has a perfect square inside of it. It's 9 times 3. We can then take the square root of 9, which is 3, and bring it out. So we have x is equal to plus or minus 3, and then this 3 stays in, 3 radical 3. If you have to separate it by with commas, you would say it's 3 radical 3 and -3 radical 3. So sometimes we can simplify our radicals. How about you try this? See if you can figure out how to solve the quantity v plus 1 squared minus 4 is equal to 0. Pause the video and see if you can see how to figure out how to solve this equation. I'm going to keep going. Well, because I see my variable in this parentheses and then there's a square outside, I know that this is a quadratic because my variable, even though it doesn't look like it's squared here, it's inside this parenthesis, which means it's going to be squared. So I want to take the square root, but I have this other term on the same side of the equation. I need to get that out of there. So let's add 4 to both sides. We'll take that v plus 1 quantity squared equal to 4 because this is gone. And now, even though there are multiple terms in this parentheses, I don't have to square it. I don't have to get the binomials, right? I don't have to multiply two binomials and do binomial distribution. I can just get rid of this exponent by taking the square root. Isn't it? This can be a much nicer approach. And then we're going to take plus and minus the square root of the other side. This is now x plus 1, because all this other stuff is gone, equals plus and minus. And we can do the square root of 4, right? It's 2. And now we have to solve both of these equations. So we need to be a little careful here. we have to do x plus 1 equals 2 and x plus 1 equals -2, both the plus and the minus. This will give us x equals 1, and this will give us x equals -3. So our solutions are 1 and -3. And finally, one more. That one worked out nicely because when I took this square root here, it gave me a nice, neat whole number, okay? Let's look at one where that doesn't happen. Y plus 1, quantity squared, minus 45 is equal to 0. So what I want to do is solve this and give the answer in the most simplest form possible. So just like before, we'll take this 45 and we need to eliminate it from the left side. So we'll have y plus 1 quantity squared equals positive 45. I add 45 to both sides. Now we'll take the square root of both sides. This will be plus and minus over here. The exponent will cancel. Y plus 1 equals plus or minus. Now, the square root of 45, if you think about it, has a perfect square inside of it of 9. So we can simplify this by taking the square root of, that's not what I wanted to do, taking the square root of 9 and bringing it out to the front, which gives us y plus 1 equals plus and minus 3 radical 5. Now what we will do is finish this by subtracting 1 from both sides. Now, there are a couple ways to do this. Most often, we put these extra constants out here in front of the 3 radical 5 and in front of the plus or minus symbol instead of at the end. This is a common way to do it. -1 plus or minus 3 radical 5. Or if you separate them with commas, -1 plus 3 radical 5, comma, -1 minus 3 radical 5. Now again, this -1, this -1 could come at the end, but typically we do write it out there in front. And then so we would have these two solutions. You could take the square root of 5 and get a decimal number and approximate this. But generally for problems like this, you will be asked to give it in just simplest form, which is exact. The square root symbol is exact. As soon as you calculate what that is, and you have to round it because it's an irrational number, it is no longer exact. It is only an approximation.